Okay, so today I'm going to do a couple of examples of the fission and fusion problems and just talk them through. So for number one here, we have two different hydrogen isotopes. One of them has a mass of 1, while the other has a mass of 3. So our mass on the reactant side that we're starting with is 4. And our atomic number that we're starting with on this side is 1 plus 1. So we will have 2 that we are starting with. In order to balance that out, on the other side, we will have a mass of 4 and an atomic number of 2. Using my periodic table, I am going to look up the number 2. That brings me to helium. So He. Do not come up with your own. I've had a lot of people putting just an H. That will give you a whole new element of hydrogen. All right, number 2. We have 226 for radon as the mass. And we have 88 for the atomic number. On the other side, we already have a 4. So what we're going to need to do to find the mass is do 226. We're going to subtract that 4. So 226 minus 4, that means our new number is going to have to be 222. Same for our atomic. We already have 2 on the other side of our reaction. So we'll take away 2 from that 88 we need. That will give us 86. When we look up 86 on the periodic table, please look to the far right side, and it's going to come up with radon, Rn. So radium turning into helium and radon. So when it goes from 1 to 2, this is going to be fission, larger breaking into 2 smaller. When it goes from 2 to 1 on the top, that is going to fuse together. All right, let's try another. So this time we're trying to find what the reactants are. So what's going in, we already know what's coming out. So the mass on this side, we have 4 plus 208 is going to give us 212. For the atomic number, or number of protons, we have 2 plus 81. It's going to give us 83. So if we have 212 and 83, 83 on the periodic table is going to be close to radon. It is bismuth, Bi. Bi. If we are going from a 1 to 2 again, that is going to be fission. All right, we're going to try this number 4 that has the neutron on the product side. So when we have that, we just have to remember that it is only mass and it does not give us any protons. It does not affect the atomic number. So on the reactant side, the mass, we have 238 plus 4. It's going to give us 242. The atomic number, we have 92 protons in uranium plus 2 in our helium is going to give us 94. So we want the other side to also have a mass of 242 total and an atomic number of 94 total. So for mass, we already have a 1. So that's going to mean 241 for the mass and 94 for the atomic number. So when I look up 94, 94 is going to be on the very bottom for the actinides. It is Pu. Pu. So this one is breaking from 2 and it's fusing to make 1 and releasing a neutron while it goes. So from 2 to 1, we are going to fuse together.